Greetings, my name is Bernard Spanda. I am a Cardano Intersect developer advocate. Right here, I want to walk to demo an NFT smart contract using Helios and coxylib library. This is just an experiment because I want to run developer advocate series for onboarding new developers. I always believe in let's use what is easy and let's grow in Cardano from simple to complex. Okay, let me check if this is recording what I want. Hope you can see my screen. Let me just reload this part. Let me open the index file. Right. Okay. Right, this is what you can see here. Let's see if we are together. This is a demo one. I want to check my voice, my volume. Maybe we can have some little bit of background music. I like this inspirational music. I'll keep it low. I'll keep it very low. Good. At least. And there is that little background music. And my voice is beginning to get confident of what I'm doing. Right, Bernard, let's get started. First, let's see what is going to run. Let us first sell some tokens. Number one, sell tokens from my wallet. Okay, let's look at my wallet. Right, I've got a wallet. I'm going to select WIMS. A bunch of tokens here under WIMS. The first one is this Gimba Labs token, which I created when I was learning how to code. Then after that, I'm going to then buy tokens using different accounts. Okay, this is what we are going to do just right now. Let's go. First thing is I'm running this sell function from coxylib here, and then I'm giving it a smart contract called demo. We'll look into the details of this smart contract later. So basically, what I'm selling, I'm selling an asset. I'm going to pick the first asset, which I've shown you here. It's going to pick this one here. I have 910 of those tokens. But in this session, I'm only selling, let me sell 5. And then each price is going to be 3 ETA, which is 3 million Loveless. Then it means if I sell all of them, I must get 9 times 3. must give me this. So ignore this for now. It is corrected inside here. Right, I'm going to call this cell number 3 for now. All these are going to be automatically filled when this function runs. They will be updated. Okay. Let's running this. You can see here. This is the folder where that source code is. It's using shared hosting, which is the most popular in the world. Okay, let's run it. So this pops up. Let's see, what am I selling? I'm selling asset. I'm selling 5 WIMS BU test tokens. BU test token. Oh yeah, it's EBU test token. When I was doing a Haskell training at EBU University, I got certified in Haskell Bluetooth through EBU Luxembourg. That is when I minted these tokens. Going to sell them. Quantity here is I'm selling 5. So 5 at 3 ADA each, I must get 15. So you need to see here before I go. I think the best thing what I can do first is let me move these tokens to a clean account, because you won't see the money here. I've got test 10 here, which has nothing. So on test 10, let me send ADA and tokens. There's a bug, then I'll know what to do. First, let's send the ADA, because that account doesn't have ADA. Okay, let me just send 50. I can send ADA as well as assets. I can send some of these assets here. I'll send 10. So let me send, sign. Right, meanwhile this transaction is running. A couple of explanations for you. Right, the shared hosting is very easy. It's the most popular for static website or PHP based websites. Now we are able to just integrate Cardano smart contract through the coxylib, which is a wrapper around some of the classes and functions of Helios smart contract. I'm not going into details about those ones later, but I can just show you. Here is the on-chain Helios smart contract. There will be a lesson to go through this Helios on-chain smart contract. And then let me show you the other libraries, the coxylib. It's this one here. This is just a template, making things easy for everyone. And then for tracing and debugging, so that we can see front-end performance, we use this Chimba.js. And then if you look at the demo itself, it has got a J log, a Chimba log tracing. Those are functions that are going to trace through the execution of the validator and give us some information if there are some errors. But this one I eliminated errors so that we can see what is happening. It's debugged. Okay, so this is the calling part. It is using those functions. Let's just check now. I think the transaction has gone through. Then we can go to 10. Yes, let's go to 10 and start from there. So our test 10 is 48 test header, and then now it is 10 tokens to sell. So I'm going to have buyers. The buyers are going to be test 9. Let's see, test 9 has got that token. Yes, test 9 already bought 2. So let's go to test 7. Test 7 doesn't have that EPU token. So I'm going to use test 7, test 9, and test 8. Test 8. Let's check test 8. It doesn't have. So I will use these 3 different buyers. So from here now, I start selling. Cool. Let's start. Let's see. Right, there we go. Let's just check. We are selling 5. Okay, let's sign. Alright, so from this account, I have sold 5. So when this runs, it is just going to take 5, put them on the smart contract for sale. Can just wait a little bit. You'll see the sale go off, run. If you want to track, this gives you a transaction hash. Other transaction hash you have is this one here. You can use this on pre-prod CX Explorer. It will work. There we go. I think our transactions are going now. Just a minute. Right. Meanwhile, we can okay, let's check now. I still have 10. It's a bit slow. These things are running on chain, so it is a testnet chain. Need a little bit of patience. And meanwhile, I'm going to switch over to buying. Going to call this buy function. Going to buy. I'm selling 5, so the first ones I'm going to buy are 2 from here. Going to use another account. Not sure here why. Let's move on to another account. Account 9. So, right, using account 9, let's buy 2 to make it 4. Right, I'm going to run now. It should pick up the cell. There, it has picked up the cell. So that wallet is taking long to update. What am I buying now? Buying 2 of those tokens. And then, which means I'm going to have 4 in this account. Just 9. Let me sign. Sometimes you see the buying transaction has gone through. It should update both the selling account and the buying account. There, this one was very fast. So if we go to the selling account, which is test 10, there we go. See, it is updated now. But now we have managed to sell 2. So here we must have gained an extra 2 times 3, 6 adder. Didn't check here. It was the balance before. If we check here, we are going to see we gained 6 adder. The 6 adder that came here. So if we go to the pre-prod, I prefer the CX pre-prod.cx Explorer. It shows more details in a clear way on that one. There are different explorers you can use. So 1 minute ago, you can see, let's look at, there it is. Here we've got a transaction. You can see the smart contract. You can see 2 tokens have been sold. You can see 6 adder has been sent by the buyer. There's the buyer lost that 6 adder. And then you can see this one went to the seller. It's direct. This is a direct atomic swap. Doesn't store the money in the smart contract, this one. So the seller immediately gets money and the buyer has got tokens, so it's decentralized. Right, let's go back. This time we are going to use another wallet. We go to, we used 9, now we are going to use 8. 8 doesn't have that token. 8 is going to lose. It's going to buy, let's say 1. So it's going to lose 3 adder and gain 1 extra token. So 3 adder plus 51 for 10 must be around 54. Okay. So let's buy. I'm running the buy function here, buying 2 tokens. You see it working. There we go. I'm losing 6. I'm buying 2 tokens using a test 8. So we wait here and we must get our 2 tokens of EBU tokens. It is awesome. So tokens left must be on the smart contract. There must be 1 because I've already, yeah, there we go. So now let us go to test 10. 51 plus 3 or plus 6 must be 57. So you can see I am selling my tokens. I'm making money. It's atomic, it's decentralized. My money is not going to a smart contract where people can see and then try to steal it. Purely decentralized. So we still have got 1 more token for sale. You can go to test 7. On test 7 you can see it doesn't have that token. Gonna lose 3. So I must be having 18 or 17 with transaction fee taken out. Let's run, let's buy. This knows already where the token is. And it knows how much is left. Right, I didn't correct that. I want you to see one thing here. Here it is saying I'm buying 1. But I didn't correct the quantity. Why? Because the logic checks the quantity is more than what is available. It only gives you what is available and takes money from you for what is available. Okay, so that is what I want you to see. I'm not losing 6 ADA, I'm only losing 3. There we go. So there we go. This is test 8, test 7. So test 7 is going to get a third token. And then it's going to lose 3 ADA. Let's just wait for this one to reload, show a new difference on the ADA that is available balance there. Also it shows tokens that are there. Meanwhile, I can be telling you the advantages of this. This unlocks a lot. There we go, 17. There we have got a token that we have bought. Then if we look at the seller now, seller now is smiling. I've sold all my tokens. Wow. Coxylib, helios, so quick, so easy, so fast. This is it from me, Bernard, the Cardano developer advocate. Let me stop sharing. How do I stop sharing from here? Presentation, fuel presentation. How do I just stop sharing from this? But it doesn't matter as long as you can see me. See how happy I am. You must buy this cap. You must join this intersect, become a paid member, and enjoy what I'm enjoying. It's not only this, also the t-shirt. See that? I think you can see. There we go. Wonderful. I'm going to stop recording. Where do you find me now? How do we work together? Before I record. Right, I've got 2 groups. Let's go to where you can join. Go to Discord. We have got for Intersect, new developers. We have got a channel here where I assist all of new people here. Cardano open source. Let me share so that you see it. The best way to contact me is via coxylib. I think sharing that. You can see my screen is still shared. Don't know how to stop it from sharing. So I've got this one here, Cardano open source. Here when you join, you must use COS this one here. It's happening here. Yeah, you join this channel here. Join here, there are already groups for students, group 1 to 7. But any other who is not a student, wants to work, teach, mentor, you will work with this COS open. Listen to this. Welcome to this channel. This is an open channel for anyone that must be focused on Cardano open source. It is not for students because students are already grouped there. But for young and seasoned developers, it will have its own ADA incentives. Already, let me tell you, group 1 up to group 7, these who are here, they have got 10,500 runs. for this, for the group work that is there. How much is that in terms of ADA? It's around 500 ADA, if I'm not wrong. Close to 500, around 500 ADA for them. So there's going to be incentives for anyone who is going to join here. You are going to be a mentor if you already know how to assist with Cardano open source repositories. Details will come to you when you join. Now, I have another coxylib, where that helios and coxylib come from. So there is a Discord for that one. There it is, coxygen. So here it is. I will put the links onto this video. Okay. There is a website for coxygen. Just say coxygen.com. Coxygen. There we go. So it's very easy to find. https://coxygen.com. Then it will put this for you. It's a very simple URL to follow. Here you can book, you can apply, you can do all these things. Right, there is also, where do you download the source code that you saw me here working on so that you can use it? It's very simple. It has no dependencies. Helios has 0 dependencies. Coxylib is a wraparound Helios. No dependencies. You don't even need to use bunglers, transpilers, Node.js. You don't need. It works straight on your desktop because it is HTML, CSS, and JavaScript. But on your browser, you will need to add a Cardano wallet as an extension. This is the maybe dependence that you will need so that you send your token straight to the testnet and from the testnet. How does this become a game changer? Since 2021, Bluetooth Core smart contract development with Haskell, we have been using what we call emulators, which we're not sending anything to the testnet or blockchain. They were just emulators. Here we are not working with emulators. We are working direct with a pre-production testnet, which straight away you can deploy to the mainnet once you are audited and you are happy with your smart contract. That is one advantage. Second advantage is, shared hosting is one of the most widely used hosting. It is an upgrade from it used to be called static hosting. Now we've got all these Web 2 applications running on shared hosting. On the application side, web applications are the most used everywhere because they run on the browser. See, anyone with a browser accesses your dep, Cardano dep. Here we have Cardano now, everywhere available through simple coxylib library. Here is another advantage that you need to think about. You can see here from the code, you design, develop, test, and deploy one time. Yes. So you can see from here, you can see your own chain. You are able to see your own chain execution and tracing. I'll show you. So I'm just going to go to the actual on-chain code. Switch on this run tracing and logging. So just say true. And then from here, we can introduce an error here. We might not see the error from the buy side, but we might see the error from from the sell side. We might see the error from the buy. Why? Because the buy is the redeemer. This code is going to run when you run the buy. There is a redeemer. But we can try to see if on the sell side we can see this tracing here. We can try and see that. So let's run. If I run here, I'm on the buy side because I've changed the smart contract script. So it will require, so the script address has changed. So it will require me to start with a buy. Okay, let's go. Let me see where I am. But here I've got 5. I can still sell whatever I have did. I can still sell it. So let me run. Let me see if there is an error here. So I'm going to take out this one here. Just want to see if you can see the on chain. All right, on this side it doesn't tell you, but it does tell you straight that on the demo 155, which is the on chain part, this is undefined. So it picks up the errors from here. Let's pick up tracing and locking from the redeemer side. You will see what I mean. So let me sell 1. Selling 5. Let me sell 1. Okay, now I'm going to turn to the buy side. The most important thing I want you to see here is the on-chain logic tracing. Now we are just going to change the logic. Right, this now is going to show. Okay, so we've got some logic here. The first logic, second, third, fourth. Right, here we said we want this to be greater or equal. So let's say we want it to be smaller. Immediately this is going to fail. The logic is not correct. The most important thing is you'll see. Alright, we are still waiting for the UTXO to be available. So which means what we solved, transaction is still running. Oh yeah, now the transaction is. So I can use any other. Let me use test 9. Okay. So let me run this. So now it must find the script because the transaction is confirmed. There it is. Okay. It's not, says no UTXO found. Oh yes, because I altered this after selling. So now it created a different UTXO. So the moment you sell something, you don't change the script. The moment you change it, it will detect changes have done. Then immediately you won't find the UTXO where you made a sell. That is a very good security. Okay, there we go. So in this case, I'm selling something from this side, test 9. Yeah, I'm selling one from test. Yeah, let me go to test 8. What you don't need to do, test 8 here. Moment you have created a sale using the smart contract, this one must not be tampered with. You can go ahead to your buy. Anyone who has access to the smart contract, if he or she changes, then the transaction will never go through. So from here now on test 8, let me run it. We are going to see the on-chain. Yeah, this is the on-chain you can see the logging, the tracing, the testing. So if we check here, it tells us that the validator failed. The transaction cannot run because the logic is not right. So if we check, is it signed by the buyer? True. That's correct. So it means this one here is true. Then this one here we have to check that the ID NFT we are selling is equal to the ID specified in the datum. And then we can see that indeed this is the datum NFT ID. You can see it is equal to this one, which is supplied on the redeemer by the buyer. So that number 2 is correct. So this one here is correct. Then when we go to check this line here, if the buyer is going to get what he is buying, the tokens he is buying, specified by the redeemer, you can see here it says correct. So which means what I'm buying I'm going to get. So this part, the logic is correct. Now let us go to the seller now. If we look at this other logic here, what we are saying here is value sent to the seller. Remember, you are taking tokens from the seller, so you have to give the seller the correct amount of ADA, test ADA. So that Loveless must be less than, see, what the NFT price multiplied by the quantity. It should be the other way around. So the logic here is wrong. Logic here it must be, this must be greater or equal to this, so that the seller gets the correct amount, gets correct or more by mistake, whatever. If you like to donate some extra is fine, but not less. So this is what made everything fail, because it's the last logic on this on-chain contract. These are Jimba logging so that you can see the values of your logic here. It's very good for testing, for tracing, for seeing your not only runtime errors but also logical errors there. So it's an end-to-end testing. So what do you see here? You can see from here that I've got the on-chain on the console. At the same time, we have got this test, the JavaScript client-side testing. You can see some of these failures are not really failures. It is the Jimba is failing to really construe the value of the object. you can see it flags when it fails, so which means Jimba needs to be improved also. So one most important advantage of this template or library is open source. Everyone can get it, improve on it, and share with me and others what you've got. Here you have got one project in one folder where you code your own chain, test your own chain, then run the front side, test the front side, all in one. You develop, deploy, and test, and then even make it live. I simply have to send this to anyone anywhere in the world to run and mint tokens using this testnet library. Want to hear what your thoughts are? Feel free, contact me, give me feedback, let us improve. Because it is running using static HTML, using simple JavaScript, then you can integrate it on any other application, web applications. You can use Node.js, you can use VS Code, you can use whatever you have. It's easy to integrate with other because it has less dependencies, zero dependencies, because of Helios and coxylib. Thank you very much once again. My name is Bernard Spanda, the developer advocate for Intersect. I'm the founder of Coxygen Global, which is a Cardano smart contract technical live support. It runs every day. Coxygen Global runs sessions. Coxygen Global runs sessions every day from 10:30 till around 4 o'clock using South African time. Anyone is free, is welcome to join and take part there. Thank you. If you like to assist by donation, you're welcome. You can donate your hours, be a mentor, help us to understand deeper Bluetooth core, even deeper, the EUTXO model, even deeper, help us understand deeper the validations. What is the next step from here? Next step is to upgrade that smart contract for buying and selling, add upgradability using SIP68, and then add more smart contracts so that it's not only one smart contract running, it's 2-3 different smart contracts doing various features, adding various features. Okay, thank you very much. Let me stop here.